Okay. New lab control room. Okay, it just went away since I'm already streaming. Of course I am. You know, it's all good. It's all good. Okay. I'm annoyed. Very annoyed indeed. Because for some reason, my OBS. Oh, hang on. I'll just start again. Alright. I am annoyed. Very annoyed indeed. Because for some reason, my OBS forgot what it was. And so, hello. That was very quick, Valerie Silva. Welcome aboard. Wait. This is not an SFM live stream, actually. This is Quilomena dies in Unity. Making gaming pancakes. Bacon games. Making bacon games. Not actually featuring bacon. That's a lot of people. Hello. And this is actually in... I would classify this as science and technology. So right now it's all black. Because my OBS is a dingus. Okay, so I need to reset pretty much everything. So the first part of this live stream is going to be just me fixing up my OBS because it is dumb. Okay, so this is a border one. Okay, and I'm gonna browse. You can't actually see this, that's why I'm dictating what I'm doing. And it is in fact in biggest voice. The reason why it died is because of the fact that I accidentally opened up OBS without having my hard drive connected, so everything is dead. And that's my fault. Yeah, that's my fault, and that's what I'm fixing. So I currently just got my border in the place. Okay. The next thing that I need, it's going to be pretty great to set this up again. So I'm going to call this stupid face. Cool. All right. And that's currently seeing an upside down face, which is nice. Where did my border go? Okay. Match output FES. Okay, that's fine. Deactivate. Yeah, we're not showing, that's fine. Okay, cool. Where did my border go? Why is my border not there? What? Oh, come on. Straight, open, okay. Alright, silly. Alright, cool. I'm going to go ahead and put this in the bottom right corner. There it is. And of course, it's going to be below the border. Very nice. So you can see it's right there, and it's nice. And I'm just going to go ahead and... Oh, okay. Okay. I don't know where to put it. I'm sitting down again, by the way. Yeah, I've rejoined the sitting down club. Hello, how is everyone? It's amazing how many people have joined in on this bloody not the amount of people, but like the amount of like talking that's happening. I really appreciate it. How's it going? Valerie Silva, Tayala Cohen, and Christopher Piner Jr. I'm doing quite well. Yourself? All right. So that's now in the right. Hello. Hi. You can see me now. I'm going to go ahead and add another image, which is the stream image, I guess. I'm going to call it stream background image. Okay, stream background image. Okay. I'm going to browse. I need to go down to stream picture with no glow. There it is. Big boy. Okay. It's coming down. Alright, I'm going to put this here. And of course it needs to be behind the border. And I'm going to put this right over right there-ish. And I'm actually going to add another background image. I'm going to put it as the background behind here. Oh, well, actually, no, that's fine. It's fine. I can do this. There we go. And so we've got two different versions, and this top one is here for when there's no screen showing. And I'm going to go ahead and add a text. I'm going to call it no screen text. Okay. Add. And I'm going to call this no capture at the moment. Hang in there, chief. You dropped this king, alright? And the background color, of course, needs to be just a little bit so you can actually see it. Actually, I'm going to add an outline. No background, just outline. And the outline color is going to be black. Cool. And the outline size is going to be... Yeah, the outline is a new feature. Outline is a new feature, and I'm so glad it's here. I'm not sure if it is actually a new feature, but I don't remember seeing it. No capture at the moment. Hang in there, chief. Cool. Actually, I'm also going to make it alignment center. There we go. Cool. No capture at the moment. Hang in there, chief. Cool. All right. All right. And the next thing is going to be a media source. Yeah, I think it is. Media source for stream loop. Go ahead and loop stream loop. Okay. And the file I'm going to be doing it is in stream materials. It's going to be Twyreed. It's my favorite one, to be honest. Okay. There she is. There she's reading the book. I'm going to put it down in the bottom right corner here. And of course, I need to make sure she's behind the border. Everything needs to be behind the border. I'm actually also going to I'm gonna rename this. Oh crap. Okay. I'm gonna rename this to just border. Stream border. Yeah, like I'm saying things like this, and I'm going to rename this. Why is it gone again? What? I didn't tell you to do. Oh, do I need to specifically say for it to keep repeating the thing? That'd be dumb if I needed to add another border. Okay, just because I like having it double strength if I needed to. I'm not going to have this one a double strength, but when I use the squiggly border, I do need to have it double strength. Why? Okay, loop. There it is. All right, cool. All right, so that one's there. Okay, cool. I'm going to go ahead and add window capture. Create new. I'm going to call this one screen capture because I like changing the name of things. Screen capture. Hello. That's not the screen I want you to do. No, window capture is not what I wanted. No, that's not what I wanted. I wanted display capture. That's the one. Display capture. There we go. Now you can see that we're looking into the void here. That's not actually. Oh, whoops. Oops. Oops. Oh no. Yeah. All right. Cool. Okay, that should be fine. Display capture here. I'm gonna go ahead and put it there. And I'm going to put it beneath. Oh, the screen capture needs to die. Remove. Yes. So screen capture is going to go underneath the border, underneath, not underneath that one. That one needs to stay with that. Underneath the stream loop, underneath the stream, no. Stream background image. This one has to go underneath. Oh no. Oh no. Okay, so I'm gonna have to set up a filter on this one, which is a pan and crop filter, or crop and pad, that is. Okay. And I'm going to have to make sure that this one is in fact above the display capture, but I have to make sure that this one is below the display capture, right? And this one, I'm going to... Good lord, this is going to take a while. I'm going to make it as, I think it's like 1,000. I'm going to put it as 1,000. No. Not relative. What? What? Oh. Okay, cool. Oh, it's 4K. Oh, shit. I can't remember the dimensions for 4K. It should just be double these guys, right? So that's 23840. And this one is 2160. There we go. Cool. 3840 by 2160. And Y. What does Y mean? Oh, that's its going up amount. So I need to make this one go up by 1920. Right? Near. The width, the height, I need to wait, 1080. There we go. But not really. I need to make sure that this goes up. Yes, so this one needs to come up by 1080. Oh, actually, no. I can do 38. No, I can do 2160 here. Damn it! Heck. All right. So that's 540. There we go. That's what I'm after. All right. Cool. And then what I could do, selecting this guy. Oh god, there's one. Okay, there we go. And then I can just move him down here. Does that work? I think it works. Because we've got angry little Quillo there on the left. So it's fine. It's fine, guys. It's fine. Stop resizing it, Steve. You don't need to. That's fine. Cool. All right. Sweet. And the next thing I can actually do here is on the stream background image here, for the filters, I can actually bring it up slightly. So make this one instead like 800. Yeah, there we go. That's easy. Nice. Very nice. There we go. We've got his angry eyes and his angry mouth here. Excellent stuff. Yeah, look at Twilight, read her little book. It's good. Okay, so I need to get you guys down over here. So what I need to do is open up the YouTube chat, and then I need to copy this link. Cool. And then I'm going to open here and do a browser. Browsers are actually really awesome. YouTube chat. Cool. Okay. So this is the YouTube chat, and what I can do is boom, do that, and I can also set the oh, where is it? Where is it? Oh, it's at the top here. Okay, cool. So I can do that, and then I can also set filters. Right? I'm gonna set a crop and pad. Right? And this one specifically is to get rid of going up to the say something, just above the say something. You can see it slowly going away here. And the thing about that say something is that it has the same dimensions no matter what size of the screen it is. So it's yeah, it's just here. That's all I need. And then my next thing that I need to do is change the dimensions of this YouTube chat. I should have changed the dimensions first. So I'm going to change this to 800 and this one down to 200. Sorry for hitting the mic. Okay, maybe not 800 by 200. Maybe 1000 by 300. Okay, so a little bit further still. So maybe that's actually 900 and this is actually 350. Okay. So maybe this is actually 975 and this one is 325. It's almost there. It's about right. In fact, I would say that that's precisely right. Oh, and the other thing is I need to get rid of this top part. But that's easy. That's easy because all I need to do is bring the height up to about like 175. Add another whoopsie daisies. I meant to say 1075. Yes. 1075 and just move it up a bit. Move it up a tad bit. Okay, maybe not 1075. Maybe 1025. 25. There it goes. Very nice. And of course I need to make it a bit wider as well so I can get rid of the scroll bar. So let's have a look. If we just make this 335, just to get out. Perfect. Perfecto. The perfect toe. I can say wee and it appears in the chat. There it is, wee. Good stuff. Good stuff. Okay, so this screen is all nice and set up. So what are we going to do today? Today... You can't look at my stick bugs. Half-Life Mosquito. Okay, Bob sent me something. Uh-oh. Okay, ready? Are you ready for this? Oh, wait, you can't hear anything. Hang on. I turned off the desktop audio. Okay, ready? Are you ready for this? Ready?
I wonder if I should run that... Oh, no.
Good old bloody Half-Life 2 sound effects. Actually, that's Half-Life 1 sound effect. Good stuff. It's good stuff. Anyway, so that's that. Okay, so what are we going to do today? I am going to cry in Unity. So there was this person, or I'm just going to search her up real quick, who made a Unity game using only particles. So Unity game using only particles. Here it is. So her name is Zyga, and she made a Unity game using only particles. It's not Squarespace. I don't want it. All right. Okay, so this essentially sums up her experience with it.
This was the worst decision of my life.
And if you had any reservations about her not being a programmer, that should have solidified it for you that she absolutely 100% is. Most of my programming life is summed up with the first 3 seconds of this video.
This was the worst decision of my life.
It's great. All right. Anyway, so oh wait, I should have shown more thing about the game. Okay, so the game that she made. The game that she made, if I just turn off the audio for a sec, the game that she made was essentially like an Earth defense sort of thing, where you're this guy that has to go around defending things. And the way that she used the particles is actually kind of awesome. Yes, double thumb. Oh, 30. Okay. Like complain. Okay, whatever. The way that she used the particles is actually kind of cool. Everything you see here is actually a particle system, which I think is brilliant, including the text. She somehow managed to make the text from a particle system. I thought that was kind of brilliant. I'm not going to be doing that as much, so my game is going to be a lot less strict than her version, which is pretty awesome. The thing also that's amazing is that this ring around is also a particle effect. The only thing that's not really quote-unquote a particle effect are the shaders, but that's not really a part of it. It's not really a part of the game, I guess, but it's fine. But yeah, so everything you see is made of particle effects. But she only used the particle effects as more of a more of just like a stand-in for the actual models of the things. So this game could run without particle effects. And what I intend to do is to make a game that can only run with particle effects, you know? And I intend to use the full extent of the Unity particle system in my game. And yes, it's good old background by the Miss Cadet Redshirt. Good lass. All right, so that's not true. I need to locate, because I don't want to be spending the first 6 hours of my live stream installing Unity. Oh shit. Oh no, Big Boy has the Unity things versions. There it is. That's the one. That one? Is it that one? Yeah, it's that one. Okay, cool. All right, so that's that one, and I need to add my project. Big Boy. Unity projects. Particle System Conquest. So, Particle System Conquest. I've done a little bit of it. A tiny bit of it. Just to show you what you can actually do with particle systems. This is one of the areas that I really like messing around with in Unity. Because it's actually... it's quite amazing the extent of control you can have over your particle systems in Unity. Okay, go ahead. You can hack into my you can hack into my hard drive. Okay. So
I don't even have any packages on this thing. Oh, I've got bloody Text Mesh Pro, and that's it. So I started programming this game on my laptop, and then I put it on a hard drive and moved it over to my desktop. That's taking a while. Welcome to Unity. Oh, that kind of spawned in, right? That's brilliant. Kind of undermining my bloody authority here. Okay, so this is the current thing of what I'm doing. And the idea that I had for a particle system driven game was a lot like the Cell Conquest games that you can find in many Flash game websites, where you have like a base that generates units and you send like half of those units over to another base, and if you've got more in that army than the target, then that target, like you'll fight things in that target, and then you can take over, and you'll have another base to spawn units. So you can, it's like an army generation sort of conquest game that I really like. And this is what I've got currently. I have code that actually moves the particles themselves, and what I'm doing to simulate the actual size of the base is having specific program, or specific, there it is in the inspector, specific variables in a script that I can control. To make the bases better or worse. So right now I've got the blue base selected, and if I say make the maximum 1,000, then more guys will be spawning in to increase this count, and I can make the spawn rate higher to make it go like this, and the initial count is only works at the beginning of the map, and you can see as more bits, more boyos get into this base, it gets larger and larger, and it takes up more space, which is pretty cool. And of course, one thing that you can do is send a whole bunch of armies to a cell that you use, so you can actually put more boys in a put more boys than you can actually contain in a cell, and I'll be able to like integrate with that. And if you do that though, the guys that can't fit will end up like, so if I simulate it by, say I just put a thousand boys into that one thing, and this thing can only hold 100, it'll start destroying the guys really quickly. And you can see as soon as they came past, they ended up getting smaller and smaller. I think it's a bit too quick though, a bit too quick, because I can imagine that if you have, say, 200 boyos coming here, and then you put 100 on them. Oh, that's not actually too bad. That's not actually too bad. But I still might slow it down a bit, but increase the rate. Like, slow down the actual diminishing, but increase the rate. Anyway, let's get into Visual Studio. Okay, so I'm going to go ahead and open up Edit Script. There we go. I'm going to head and open up Visual Studio to see if we can make this good. Let's see if it recognizes the solution project file. Solution. Or is it just a single one? No, it's okay. It's good. It's all of it. All right, sweet. So this is my Visual Studio, and we're going to have a look at some code. So, damn it. Ah, damn it. Ah, damn it. Ah, damn it. Why is it not doing that? Oh, it's not using the... Heck in the heck. So obviously, it's breaking a bit, which is not good. There was a small, simple thing that I needed to do to get it to work properly. So those white text with the red underlines shouldn't actually be errors, but it's pulling it up as an error. And it's coming over here, but it's not understanding this section here, because this is from Unity Engine, and it doesn't seem to want to be right. But there was a simple solution to it. Very simple solution. That I forgot. Is it sync with active document? No. Okay, so I don't need to generate a new class component because that should just be there. Welcome to technical difficulties, the stream. Okay. Well, I can set that up real quick. Make it easy. Okay, cool. Feck. Oh, okay, it's working now. Why is it? Okay. It suddenly started working. I don't know why, but it's working now. Okay, cool. So you can see that this is a completed. Oh, no, it's not completed, but it's a mostly complete file. And the thing that I'm really excited about is this part here. So what this function is doing, this move particles function, is it's grabbing all of the live particles in each individual base. So just consider one base for now. It's just the one. Okay. So just consider the one base. In fact, what I'll do is I'll actually stop this and just have the white base operative. There we go. So we've got the neutral base here. And there we go. It spawns with an additional of 20, and you can see how the little cell boys are moving around. And the way I've defined it is that, okay, so it's going to grab all the live particles. It's going to enter a for loop that is the size of the particle, so it's just going to iterate through each particle. And it's going to add a random direction within. It's gonna add on a random direction in a tiny box of like 0.1 by 0.1 by 0, well, technically 0.2. So you imagine this box having side lengths. So here's one side length, here's another, and so it's a box having side length of 0.2, right? Side length of 0.2, with the origin point 0, 0, 0 being in the center of this box. And it's going to pick a random point inside this box to add to the particle's current velocity, and that happens every frame. So every single frame, a random point in this box is going to be added onto the. So here's the particle. Here's its current direction. It's going to be added onto the direction of the particle, and it's going to be in 3D space. Currently, the camera is orthographically projected, so that the text lines up properly. But I might play around with perspective so you could actually see the 3D things happening. Oh, all right. So that's what it does every frame. It adds a random direction onto each individual particle. Okay. This next part here is asking if so this one is asking if the position of that particle point is a certain distance away from the center of the base. So this is the center of this is the distance away from the center of the base. This is the center of the base, and it's asking a vector that is the position of the point to the center of the base, and asking for that length. So it's asking for the distance between the particle and the center of the base. And it's asking if it's greater than a min distance, which is what I've set up here, and I might change that a bit, but it's something I can do. Multiplied by the ceiling of the particle count divided by 100. So I might actually make that something like 200 or something silly like that or something. I might actually add logarithmics in here because, like, as the circle increases, right, it actually increases the area by, I guess, a squared amount or something like that. It's something silly. Pi r squared, right, is how do you calculate the area. So as the radius increases, the area increases by a square. So if you increase the area of a circle by 1, if you increase the area of the circle from 1 to 2, so you're actually increasing the area by, I think, like 4 or 3 or something like that. It's something silly. I don't exactly know the maths myself, but it increases with the square of the radius. So I might actually add a logarithmic function here to make it so that the more particles you put into it, the less it'll actually grow up. But right now it's currently a linear expansion, and I've just made it a little bit slower to increase. But yeah, so that's that. All right, so this is asking if it is outside the range of this minimum distance. If the particle is outside the range of this minimal distance, we are going to get its velocity and add on the we're gonna get the particle, right? This is the particle. This is the center of the point. Okay, this is the center of the base, and here's the particle. Right, so here's the particle here, and here's the center of the base. As it goes outside of its range, right, it's going to add on the what I've highlighted right now is the vector that is from this point that's defined by the particle to the center of the base. So it's this vector that, if you can imagine a line with an arrow being drawn towards this part here, that's what that line is. And it's going to multiply that by the particle acceleration, which is not as fancy as it sounds. It's just particle acceleration is a thing I've defined here, which I can change later on, which is currently at 1. So at the moment, this one doesn't change it, but the thing that does change it is this time.delta time. So the time.delta time is the time in between frames. Okay, the time it takes for one frame to go to the next one. So it's going to essentially make this vector that points from this point down here really small. It's going to be really tiny. It's going to be defined by the time it takes for a frame to work. So as a point travels outside of the range of this base, it's going to turn around essentially, or it's just going to go back to the center of this base, or back into the range. And then of course, if it is inside this thing, or rather if it's greater than the maximum particle speed that I've defined, it's going to slow it down. That's what this one does. It just slows it down. All right. However, if it's inside the circle, so you can see here, if this is outside the circle, if it's inside the circle, it's just going to make sure it's still up to speed. So this randomness here might make it slow down, or it might make it speed up. This just makes sure it doesn't slow down too fast. And if it does slow down, then it brings it back up to speed based off of an acceleration quotient. This does actually have the potential of a particle inside the radius being incredibly quick. But if it's really fast, then it'll go outside and then slow down, and then come back in. So it should be fine. It should be fine. So this line here is actually my most favorite line, because if I get rid of it real quick, we'll see how the particle systems used to move. Come on, all right. So if we got rid of it, right, you can see how the particle systems would move. It generates it, and the particles move in a straight line. If I go ahead and edit this base here to have 1000 and a spawn rate of 1000, you can see that the particles go up and back in, and it sort of goes back in, and then it goes out and back in. And then of course, if I decrease the maximum, in fact, I've actually increased the spawn rate to like 10,000, something silly, then all of those things will die, go back down to 10, all right, and then if I bring it up to 1,000, you'll see that the things are on and back out and in and back out. So it does that sort of oscillating sort of motion, and I don't want that. So if we go back up to my code here and add that line back in, my favorite little line here, go back to the thing, give it a bit. You notice how this is what a particle system actually looks like, which is funny to me. If we go like this, make it play, and then do the same sort of motion that I did before. So set this up to 10,000, set this up to 100, 1,000, and you can see that even though this same sort of, it doesn't actually do the oscillating motion at all in this instance. Or it avoids doing the oscillating motion, that is. But you can see that it's sort of globulating. It's sort of globulating, which is a funny word that I just made up. But yeah, that's what I achieved with that one little line. And you can see the death particle appears and it does its little fancy thing. And I'm just gonna. It's the part the spawn rate was too quick. You can see how big it is. And the thing that really impresses me... Okay, so the thing that really impresses me is that there's currently 10,000 particles activated here. 10,000 things that are moving around on the screen here. And I can make it go even further. Boom. No, I can't actually. I set the maximum to be about 10,000. Because it's about 10,000 where things start to sort of break down. If I go ahead and restart this and add back in these two bases here and set all of their actually I'm going to play so I don't actually set these changes. Hello Kitty Purr 22, how's it going? Set the spawn rate up to 10,000 and then set all of these guys up to 10,000. Boom. You can see that they make a big mess, and currently there's 30,000 things that are currently active inside Unity right now. And Unity is actually powerful enough to... Oh, don't look at the thing if you're epileptic or prone to seizures, because photosensitive seizures, because it's going to be swatching between the colors a lot. The reason why it swaps between the colors a lot is because what have I... crap. Oh, okay, there we go. Okay, so the reason why it's flashing between the colors is because it's currently Z-fighting, because all of these particle systems are based upon, like, it renders based off of the center of the group of particles, and if the center of the group of particles is above the other center of the group of particles, then it will render above it, and so it's actually only rendered based off of one area. But there's 30,000 things active on the screen. In fact, actually there's 60,000 things active on the screen, because there's 30,000 here and 30,000 here, well, roughly 30,000 here. And we can see that they're actually doing quite well. But I set the maximum to 10,000 because that's how much I reasonably expect to be in a game. Now this is where it gets a bit tricky. So right now there's like there's 30,000 times about 5 or 6. So there's about 180,000 particles now being made every second. Because when each individual particle dies, they have a thing. And they used to have this big radius, so all of these particles are outside, and now they're slowly coming back into where they should be, which I think is awesome. If I just make this down to 100 and boom, and they're just down into the area in which they should occupy, which is pretty awesome. Now, the other thing that I did, I'm really excited about this, is I've actually made it so that the particles move independently of the center of the center of the base. Now, this is going to be very handy, very cool, because what I want to do is, if the base like stands out, one thing I want to do is make it so that when the level starts, the particles actually have to come in from the side, like that. It comes in from the side, and then I might actually have to make the outside speed to be a little bit quicker. But yeah, so it comes in from the outside, and then that's how it starts. And the other thing I want to do is that if two cells are close to each other and there's overlapping, like you can see here at the moment, if there's overlapping, what I want to do is set code so that the center actually pushes them out, so it actually pushes them apart a bit, but they still want to go back to their origin point. So that's my next goal. So let's go ahead and just add the speeding in section, which I'm going to do by, okay, so I need to identify the maximum zoom level. I need to identify how much of the play field that the camera can actually see. Oh, this is more complicated than I thought. Well, not really, because it's not by perspective. It's based off of this. So that's actually kind of cool. So what I'm going to do... The problem is, though, is that as I increase the the window, the perspective also increases, which is actually not something that I want, because it's quite viewport rect. Viewport coordinates. Yeah. Because it's not what I want, because that means that it would look different based off of your display, which is very bad, and that's not good. But I can assume that because I can potentially make it all relative, maybe, based off of the size of the thing, because I imagine, because in Unity you have this value here, which I think is Unity engine dot window. No, Windows. What's in Windows? Oh, that's for file operations. Yeah, no. I'm looking for screen dot things like width and height. There it is. So that's where it gets its vision from, and I should be able to identify that by the I should be able to identify that by the thing. Actually, wait. What I can do is not have the bases move in, but actually have the particles move in. So what I'll do here is I will disable the maximum speed for when it's outside, and just have both of these be on the inside. So that's if the particles are inside the range of the base. And what I will do is here at the start area here, what I will do, actually no, I'll do it in late start, which is a single frame after start. So this doesn't actually exist. This is a standard, awake, start, and update are standard functions inside Unity. So every single script you make can access this, so long as you're a part of monobehavior. So every monobehavior script will access this. Awake happens at the exact moment that this script becomes live. Start happens on the first frame that the script is being activated, and update happens on every single frame that the script is active. That is having the checkbox. If this checkbox is checked, every single frame that update function will run. There's also late update, which is I think it's late update, which happens after update, and then I think there's fixed update, because update happens every frame, but fixed update happens every physics calculation, I think. So if you have a lot of physics things going on, it's better to use late update. It's better to use fixed update as opposed to update. But it's it's very to me. It's fine. I just use update and late update when I need to. So this is here. So you can see here at the start, I'm going to put it in late start, because what I'm going to do is I am going to make a particle group here. Particle P. I'm just going to copy this one here. There it is. Okay, so my live particles is a function that I had written up here that grabs every single particle. It actually makes an array that is the length of the particle count, which is what you need to do, and then it gets the particles and returns that array. It's a bit convoluted, which is why I only want to have it happen once, which is up here in this live particles array, live particles thingy. Okay, so we're going to go ahead and grab those particles, all of them, and we are going to set, so we're going to go, we can do a for each loop, for each, maybe, should I do a for each loop? Should I do a for each loop or a for loop? For each, because I don't need to specifically get the index of those points, so I'm just going to do a for each loop. So I'm going to do particle system dot particle, particle system dot particle. Okay, so I'm going to call this one PS. Capital P. I'm going to make that one capital P, and this one's going to be lowercase p, in P. So for each individual particle inside the big array of particles, we're going to do the following operation. Wonder if you could do both. How do you mean by both? Oh, of course. And the other thing that's important is that after you change any of the particles, you need to make sure that you do set particles to be your particle array. Because that's one thing. You can edit the things, but they won't actually change anything unless you've reset the things. It's because the particles here in this live particle script is not actually a reference to the particles inside the things. It's actually, you grab the information of those particles and you copy it to this array here. And so what you then need to do is, after you've changed it, you need to put it back into the particle system. It's fine. That's all good. That's all good. So that's how you edit particles in this thing, and that's the important part of this part here. You need to get the particles, and then you need to set the particles. The same thing over here at the killing particles area. You need to get all of the particles. I'm choosing the specific one. I'm choosing the specific particle, and then I'm killing that particle, and then returning the position of that particle. That's just so I can spawn a the death system thing, and then I immediately kill the death system thing because I don't want it there. Oh, I can actually make it. I can actually do it as p.main.start lifetime. There we are. Oh, start lifetime dot constant. Yes, the constant. That's what I want. I'm pretty sure. So that means that I can change the length of the death system, the length of time that the death system stays, and it will delete the death system as soon as those particles disappear, which is fine. Which is good, which saves on space. Okay, so for each of these, what I'm going to do is I'm actually going to set the, I'm going to get the random script in there, which is fine. What I'm going to do is, I just need to set the X and the Z positions. So what I'm going to do is I'm going to do p dot position equals new vector 3. New vector 3. And it's going to be X, Y, and Z, right? This Y is going to be 0. That's fine. This X value is going to be, X is this way, so the width. So what I need to do is the X value needs to be random.range between negative screen.width divided by 2. Actually, I'm going to do it divided by... No, I'm going to divide it by 2. Oh, that is a tricky thing. Because what I want it to... Because I can't make it put it anywhere on the map. Oh, actually, I might be able to put it anywhere on the screen, and then they'll rush towards the base that they're supposed to be a part of. So let's try that. Let's actually try that. So it's going to be anywhere between whoopsie daisies. Anywhere between the screen width, the negative screen width, and the positive screen dot width. And then I actually need to go outside, and then this one is Y, and then this one is Z. And that's 0, and this one here is going to be the exact same as this, except instead of width, it's going to be height. Hecht. oh, there's no H in there. H-E-I-G-H-T. Right, my brain just fucking died. All right, cool. So that's fine. This guy. That is a problem I ran into before. So it's not going to be a for each loop. I need to do a for loop. So for int I equals 0. I is less than the length of p dot length, and I iterates by 1 every time, and instead of p here we're going to do p I. There it is. Cool. Righto. So now that should be, as soon as the game starts, these particles are going to burst in, and then they're going to spread out to any random point on the map. So let's have a look. So if we just go ahead and do this, and then... Oi! They're not doing the thing I wanted them to. Alright, that's... that's because I changed this area, this thingy over here. So this is if they're outside, and this is if they're inside the area. I feel like current with the screen window in pixels. Oh, that's silly. Okay, because that's screen width, but it's not converted to Unity units. So I need to convert it to Unity units somehow. Okay, so I'd be able to find out what that is by looking at... but that's only... So a Unity unit is this to here. Right? Wait. Stop. So I need to get the minimum and maximum here, but I'm pretty sure... Okay, I think there's something inside screen that I could use. So we've got... Orientation, no. Resolutions? No. Safe area, set resolution, sleep time out. There should be... There's not. Okay. There should be a number I can divide by, but it's not really. That won't work. To get the actual coordinates in world space of what the screen can actually see, that's what I'm looking for. And I don't know how to find it, so I'm going to go ahead and have a look at this website. So, Unity, get coordinates of what the screen can see. Screen coordinate system. Okay, that actually is useful. Understanding unit's coordinate system. Because, okay, viewport. I'm a dingus. All right, viewport is what I actually want. Viewport doesn't exist. Cool. All right. Screen height, viewport. There it is. Camera.main.screen to world point. Okay, camera.main.screen to world point. That's what I'm looking for. Because it's the camera.main camera that's running. Screen to world point. So screen to world point. And this is a position on that screen. Transform a point from screen space to world space, where the world space is defined as the coordinate system as the very top of your game's hierarchy. Position a screen space. The variable is screen space. Position, often mouse X, Y, plus a Z position for depth. So the depth is going to be the distance from the camera, I guess. So one will be one Unity unit in front of the camera or something like that. But the X and Y are going to be determined by the points. Okay. So screen to world point. I want a random point in screen to world point, going from 0 to screen size. Pretty sure screen size and width. So screen to world point. We're going to do a random. No, we're going to do a new vector 3 which is going to be a random. This is going to be the x value. So it's a random, random dot range between 0 and screen dot width, right? And then it's going to be 0, because I don't care about the y at the moment. Actually, no, the y is important. Yeah. And then this is going to be random dot range between 0 and screen height. There it is. So it's going to be a random range between 0 and the screen height, so anywhere on the screen that is currently visible. Yeah, so that's what that is. I should potentially actually have make sure it does the maximum and minimum inside, but I'm also going to set so what I'm actually going to do is I'm going to bring I'm actually going to put this here, but particle speed, I'm going to multiply it by, I guess, I'm going to have another thing here. I'm going to say float particle outside multiplier. I'm going to make it, they can travel 5 times faster when outside the range of the thing. So particle outside multiplier. Okay, cool. All right, so velocity normalized particle speed, particle outside multiplier. So they've got a maximum speed when they're outside, so they're not going to go and then miss the bloody miss the turn off essentially. All right, okay. And so now I'm going to grab a random point that's between 0 and the screen maximum, and I'm going to return that. And that's what the X and Z position. That's what the X and Z position should be. So if I go ahead and just activate this thing so I can have a look at what it is. So this one here transforms a point from screen space to world space. Well, the world space is okay, fine, whatever. So I'm not sure if y actually means depth or y actually is the height, but we're gonna see. Okay, so this one here, we're actually going to project on the plane that is defined by the normal that begins at 0 and goes up, or rather the plane defined by the normal. So I'm going to go ahead and do vector3.project on plane. This vector should be this vector, which is a point, right? This vector, which is defined by the plane normal of vector3 dot up. Complicated mathematics. So this project on plane draws a plane which is a flat surface, a mathematically flat surface, that is defined by vector3 up, which is specifically a vector that begins at 0 and points upwards, right? And so this is the perfectly flat plane that is visible by these squares here. That's what the perfectly flat plane defined by vector3 up is. And it's going to find a point here, and then it's just going to put it on the plane there, the ground there. Sorry, again, hit the mic. Very sorry. Hello, Suplup. Welcome aboard. Okay, so we're going to get a random position, and we're going to set that position as this guy's new position. So we should see that every single point should... Okay, so the particles should appear, and then they should spread out in the screen, and then they should wiggle back into where they should be. So let's have a look. Okay. So they don't seem to be slowing down when they are going in range. Unless the maximum range for some reason was increased by a ton. y. Hang on. What is the min distance? 0.5. Okay. I wonder if I should actually put this inside the inside, only when the particles are inside, get rid of this one and put these two outside the if statement. So they're going to speed up to their minimum speed and they're going to slow down to their maximum speed. So let's have a look, see if that works. Again, it sort of does. Well, it works a hell of a lot better than previous. That's for sure. Gross. All right. I'm gonna. Do I have tissues? No. Paper. Cool. Okay. So problemo. Okay, so if they are inside the circle, they're going to slow down to their max speed. If they're outside the circle, we're going to speed it up to particle outside multiplier. That's if it's greater than, though. That's if it's greater than. Oh! Hang on. Yeah, that's if it's greater than. We want it to be less than particle speed to speed up. So that's actually the maximum one. This is the minimum. Okay. Well, that's actually the maximum, and this is the minimum speed. Okay. So that's shite. That here makes sure that they slow down. Shit. Okay, I'm going to delete this for a sec. Okay, so if the velocity is greater than the maximum speed allowed, we're going to set it to the maximum speed. Okay, cool. If the velocity is lower than the speed allowed, we're going to accelerate it up to the minimum speed. Okay, cool. So we're going to get rid of these. We're going to that and also this. Okay, so the maximum particle speed is actually going to be this plus the particle outside multiplier. Right, this is going to be the same here. So if it's greater than the particle outside multiplier, we're going to set it to the particle outside multiplier. Cool. If it's less than that, okay, so I just need to donk and then donk on the haters. Cool. We're going to speed it up to that point. All right. Let's see if that does the thing that I want it to. Not really at all, unfortunately. Yeah, so, okay. Why is it both here and there? I think I need to get rid of one of these. So when it's outside, it's not actually... Oh, I think I forgot to remove that before. So when it's outside, it's not actually going to be randomized. Alright, so let's have a look. Inside it is. But they're not slowing down when they're inside. So this is when they're inside. If it's greater than that, it's going to normalize it and set it to the maximum. Barnacles! I've got it. So the maximum speed needs to be defined by the distance the particle is from the center. See if that works. Okay. So the difference between the distance between it and the center is going to be is going to edit the maximum speed that it can actually travel. Okay. So I'm gonna get rid of these guys. Okay. So. I'm going to refactor this into its own code. I can right click and do refactorings, extract method. Local function? Method. Yeah, method. Extract method. Okay, cool. So I've got the new method here. And I'm actually going to replace this with just the particle here and get rid of I. So this pi can go away. Bada boom, beepity boopy. This new method is going to be called accelerate particle. Isn't that already a thing? It's not 2 hours. Isn't that already a thing? Oh no, particle acceleration is a thing. Silly me. Cool, accelerate particle. Alright, cool. And this one's going to be called accelerate particle, but defined by just P. Cool. Why isn't this? Oh, P, I. There we go. Cool. Accelerate particle. Alright, so this accelerate particle is going to do it based off of this. And what I actually want it to do is I actually want to make sure that the desired... Oh, actually, I'm going to need to put this down here. Desired speed. And that is a float. Desired speed is a float, and this will replace particle speed. Particle speed is the speed of the particle's speed. All right, and this is particle speed. Cool. So the particle speed is the desired speed here. Cool. Crap. Can I do out? And then make this one out? I should be able to. Okay, that should be fine. What? Use of unassigned out parameter P. But... Huh? Alright, fuck it. Equals that, and it's going to return a particle system particle. I don't understand how to use outs. It's silly. Nanny! Return P. There we go. I don't understand how to use outs, so I just do that. That's fine. It works. Okay, cool. So, the next thing that I'm going to do is I'm going to put this here, and I'm going to make the particle speed add on to this magnitude here. when it's outside that magnitude. It's going to add on that magnitude. So what I should see is that it should slow down as it approaches the center of the center of the base. It should slow down as it approaches the center of the base. My watch is dumb. It does it dumb. So it should slow down as it approaches the center of the base. Okay. Let's have a look. Sort of. It's funny. They seem to want to go outside, which is not what I wanted them to do. If you just track one of these guys, they don't actually slow down when they go to center. In fact, they're actually speeding up. All of them are actually speeding up. If we just take this to the outside here, yeah, they're actually all speeding up. I imagine if I leave this going for a while, they'll actually like continue going really fast. If I just set this up to 1,000, make it 1,000, let's have a look. So you can see that as... Yeah, when they leave, they just get faster and faster. I mean, it's a cool effect, but it's not what I'm after. Damn it. I'm trying to do a thing. I'm trying to make it so that particles that are outside the range of the base want to go towards the base. They're not doing it. They just want to speed up and keep flying around the place. It's kind of funny, but not what I'm after. Goddamn. Alright, so... Problem. Okay, one thing I can do. Oh, good lord. Oh, that's not gonna work. Particle initial speed. Right. Okay, so the only time that the particles are going to be wanting to go fast is when they spawn at the beginning. So, my solution to this is going to be that when they're outside, their speed, right, is going to be defined by the particle initial speed divided by time multiplied by like 100, so it's going to slow down a lot. So this particle initial speed is actually going to be very small, maybe 10, very small after about a second. We're going to see like the maximum speed go from like this down to like that. Hopefully, because time increases linearly, so this is going to decrease I guess, exponentially, I suppose. Yeah. Well, actually, I need to make sure it's like this. Maybe, I don't know. Oh no, that's actually gonna have an error at the beginning. So because it's gonna be 0 at the beginning, so I need to plus it by 0.01 f or something like that. Just so that it's never actually 0, because at the beginning time is going to equal 0, and that's going to be a dividing by 0 issue, and that's going to be bad. So, okay, here we go. Let's see if this works. Fuck. Let's have a look. Sort of, but not really. Okay, maybe if I make this, maybe if I just make it time, like just times time, and then this initial particle speed could just be 10. That's fine. So we're gonna see how this goes. So we're gonna play it, and then go. It is kind of funky, not gonna lie. They look like little balls of power. Okay, so it does actually need to be more than 1. So time multiplied by 5. 5 is a good number. So, hello Cadet, how's it going? Sorry, I haven't looked at the chat in a while. So what I'm trying to do is make a game that uses the Unity particle system to its fullest extent. Well, not exactly to the fullest extent, but uses the particle Unity system as much as I can actually make it. It's based off of this game that this programming lady, Zyga, had made. But you can see the way that her game is played, the particles don't actually make that, like, it's not really that important that they're actually particles. It's the same issue, like, for example, with the movie Sing. There's no reason for them to actually be animals. Like, they're not actually using... It's the difference between a movie like Sing and a movie like Zootopia, where the fact that they're animals is different. So in Zootopia, the fact that they're animals is actually incredibly integral to the plot of the story. But in Sing, it's not. They don't have to be animals. There might be a little bit of jokes here and there, but they don't have to be animals. And then this one, the particles that are featured here, they don't have to be particles. You can change it up a bit, and it'll still function as a game. So the game that she made is not bad. It's kind of cool. And you can see the particle systems that's being generated here. And you have to move it across, and then you have to protect the center thingy from the red boys. And that's fine, but they don't have to be particles here. And so the game that I'm trying to make here actually uses all of that you can do with the particle system to be able to do it. And I'm actually using the fact that particle systems want to generate things, the fact that particle system has maximum generation, the fact that particle systems, you can edit the individual particle details, and I'm using that to create a game. And I'm going to have to see if that can actually do a thing. And that's what I'm doing right now. So this is Quillo Dines in Unity a little bit further. Yeah. GameCube intro, but it's an unemployment graph. What has Bob shown with me today? Alright, let's take a small break from this and have a look at what Bob has shown me. Hang on. Can you actually hear it? No, you can't. Alright, here we go. Are you ready for this? This is the GameCube intro, but it's an unemployment graph. Oh god. Good lord. That's pure Lex. Look at it go. Oh dear lord. So that's that. Okay. Okay. So, oh, I could actually make it so that it's not randomly positioned. I can actually make it defined by the diagonal of like the hypotenuse of the triangle that is made up from the screen width and the screen height. Sorry, the screen width and the screen height, right? So I've got this hypotenuse, and I'll halve it, and then that makes a circle with a radius that just touches the corners of the screen. So I don't have to randomly position them on the screen, I can go outside. The reason why this is important is that I can do this at the very beginning of the, well, not really, actually, it's dumb. I don't have to worry about that. Okay, so, feckin' balls. I don't know what I'm doing. I think it was, like, because I didn't want them... Alright, this is Stupid Venture. Stupid Venture, we don't need to have them begin outside of the thing. Stupid Venture. Because I do want to have some kind of level intro, but obviously this is not going to work. So that's fine. This, however, was not a Stupid Venture. This is actually kind of awesome because that enables me to just do this. And then that's fine. What's this? What is it? You sent me something. No, it's fine. Yeah. So we're gonna see what happens here. So let's have a look. Yeah. So they just appear, and it's fine. It's fine. You see, it's fine. It's fine. It's fine. It's fine. It's fine. Of course. Of course. Of course. Of course. All right. Cool. So those particles appear. And they look like that, which is pretty cool. I'm happy with that. The only thing I guess I will change is to make sure that the color over lifetime is doing what I want it to. So how much lifetime does it have? It's got 999 lifetime. Whoops, that one. So you can see that they slowly appear in, and that's not what I want at all. So we're going to go do it at maybe 1%. Maybe not 1%, 0.5%. 0.1%? 0.2. Yeah, 0.2%. Okay, cool. Or maybe 0.15. Maybe 0.19. 875. Cool. Okay, so this color should be copied and pasted into these. Color over lifetime paste. Cool. So that when they appear, they don't just into existence. They actually have a bit of fade in, which is cool. Yeah, you see them sort of fading in. If I just go ahead and set the maximum particle maximum to 0, they'll all die. That's really cool. I really like that. Yeah, like, because there is definitely a point in which you need to break out of that loop to test, and then frustration, and then more testing, and then more frustration. You need to break out of that. And this is a Stupid Venture is a phrase you'll hear me say a lot, because I do that a lot. I do get into a loop of, hey, wouldn't it be cool if this, and I keep going, and then I get into a loop, and then I just break it. And then that actually, makes me frustrated with it. So we're going to get out of that loop of frustration by saying this is a Stupid Venture, and by doing something else. Okay, cool. So I think it's actually quite important for me to set up the command system. So the command system is what I got up to last time. I shouldn't worry about the size and repositioning of the particle systems just yet because it's not really required. So we'll see how it goes. So this, pardon me. So the command structure. So, right. So the command structure is going to house a game object that has a particle system in it that doesn't actually have any particles in it or any particle generation. Blech. So it doesn't actually have any particles in it, but it has a particle system. So this command structure is going to be generated when you've selected a whole bunch of origin bases. This is for the player or individual things. This is, the command structure is what's going to be used to actually play the game. The player's going to select a whole bunch of bases, and it's going to select the destination base. And what's actually going to happen is that there's going to be a command object that is created at the destination base that has a particle system that contains all of the particles that are required from the origin bases, if that makes any sense. So what I need to do is I need to have a I guess a run command. So void run command. So void run command. And I'm gonna have it be, because I also want to be able to make it so that players can determine, oh, they want to send 100% of their things or just 50% or something like that. So run command with a float value of, that is called, I guess, percent, maybe? Percent? Float percent? Oh, fuck, what am I doing? There we go. Okay, so, army size. Army percent. Cool. So army factor percent. Percent is fine. Cool. And that's going to be a value between 0 and 1. It can be higher than 1, but of course you can only send 100%. You can only send 100% of your army, so that's just what it's going to be. Okay, so army percent. And what it's going to do is that it's going to create a particle system, which I don't have to do myself. Yeah, it's going to create a particle system. Oh, and this is the part that's going to be difficult. Now, because I have this concept in my brain, right? You send a whole bunch of things and the dots will, like blob over to the destination, and then what they'll do is that they'll stay a certain distance away from the destination, and then a random point in time between like 0 and 10 seconds, say 0 and 5 seconds or something, they're going to select a particle inside the destination base and attack that particle. So what's going to happen is that they're going to generate a they're going to generate a trail from their position to the enemy and kill that enemy. Like it's important to be able to explain it, because if I can explain it, I can make it. But I right now just have to go to the bathroom, so I'll be right back. You can tell I'm a very slipper boy. Slip boy. I'll be right back. Enjoy listening to nothing for a bit. I'm good. Okay. Hi, I'm back. Welcome back. Welcome back to 69 FM, where we speak real quiet and up close to the microphone. Today, we're going to be having a guest appearance from God himself. Hello, my children. That is all. Okay, hi, welcome back. Welcome back to me. Okay, so run command, float army %. So what's going to happen is we're going to get... because what I'm going to do is I'm going to grab every single origin base. So I'm going to do a for loop for int I equals 0. I is less than origin bases. Origin bases dot length, and then I plus plus. Cool. So I'm going to iterate through all of the origin bases, and then we're going to grab the amount of particles that is defined by the army %. So I'm going to grab, say, 50% or 0.5 of the particles. So we are going to do, I guess what I'm actually... Oh, brilliant. Okay, so at the beginning, I'm going to make a particle system dot particle... Oh, hang on. Particle system dot particle list. I'm going to make a list. So a list of particle system dot particle... and I'm going to call it P. I'm using P a lot here. It's going to be a new list of particle system dot particle, a new empty list of particle system dot particle. Okay, cool. I'm going to iterate through each of the origin bases, and then we're going to go. Okay, so for int j equals 0, j is less than. Okay, origin bases with the index of I dot particle, no, count, not initial count, get part, no. Where did I get it before? Where is it? Oh, I need to make this one be public. Oh yeah. So what I'm gonna need to do is I need to make LP to be live particles. So I need to make a particle system dot particle particle system dot particle array equals origin bases I dot live particles. Particle system, and I'm gonna call this one LP. Okay, equals live particles. Right, my mic is in the way of my keyboard, and I have to see where the plus button is because I'm not exactly that best of a touch typer. It's been sending a whole bunch of stuff, and they're all amazing and adorable, and well, funny and tragic. Not good accomplishments or things. Okay, cool. And we're gonna do LP dot length, maximum of LP dot length multiplied by army %. J plus plus. Okay, so yeah, so it's going to be multiplied by the army %. The length, however, is going to be multiplied by the army %. Right. So if it's at 0.5, the length of the living particles is only going to be 50% of the length of the living particles. Cool. And what I'm going to do is I'm going to go LP J. I'm going to do P dot add LPJ. It's going to do that for every single base. So now P at this point is going to be a list of all of those bases that have been selected as part of the origin bases. And it's going to be however many percentage of those troops, or the army troops, that is going to be a part of that army. And that is what I'm going to, real quick, convert into a particle... Actually, no. Now I need to have a particle system. And make it particle system. I'm going to call it... I don't know... Oh, I've got a plasma donation tomorrow. Yeah, need to donate blood, as much blood as you can, as long as you don't have tickets to the Backstreet Boys world tour, world reunion tour. Yeah. Okay. So we've got a list of things. Hang on. Something isn't right here. Invalid token void in class struct or interface member declaration. I've got an extra right caret that I don't need. Right curly brace. Do I? No. Why is that there? What? Huh? Oh, silly me. I haven't finished writing that thing yet. Oh my god, I'm such a sped. All right, so particle system. I'm gonna call this one, I guess, order particle, or order system. So this is the particle system that is the going to be the end, or the order, I guess. And what I'm going to do is I'm going to do void awake, and inside here I'm going to set order system to equal a new particle system, if that's okay. New particle system. Right. And then this order system dot main because I don't want it to actually be emitting anything, so I can do render. Oh no. Because there's a certain option in here that makes it so that it doesn't actually do anything. I can disable the renderer. Oh no, I don't want to disable the renderer. I want to disable emission. Yeah, because I don't actually want any of this to actually mean anything for this particle system here. So this emission, enable emission, what do I use instead? Emission dot enabled equals false. And of course, it needs to be set to something different. Oh, I hate that. Okay. Because I need to make a particle system dot emission module em equals order system dot emission. Right? That's what I need to make it. And then em dot enabled equals false. Why do I have to do that? That's silly. This is silly. Anyway, so now it's not going to be emitting anything, which is desirable. Cool. So run command float army %. So I'm going to initialize I need to add a particle base. Not a particle system, but a particle base. So order system particle base order system. Oh, mate. This is kind of fucky. Put this over here. What? Sorry about that. I think my internet just disconnected for a few seconds there. Not good. Everyone still here? Yeah. I'm a bit stuck. Need to have some things going, so I'm going to be listening to something, but you won't be able to hear it. So, Okay. So... Huh. I feel like I need to make a separate thing that is defined by the order or something like that. It's a separate thing entirely. I can do that, actually. I think I should do that. I'm going to make another script, create C# script, and this is going to be something I like to call, something I should call command or attack base. Attack base. I'm going to call it an attack base. Okay? And this attack base is going to have a similar thing to the particle base. So this command system, I'm going to call this attack base. and it's going to have the order system, and this is actually going to be set to a public thing. Oh, no, capital P. Public attack base order system. And I don't have to worry about setting anything because I'm going to do it myself. And what I'm actually going to do is I'm going to initialize the attack base, right? And then inside attack base, I'm going to have the same thing here. I'm going to have the particle system be public. It's going to be a similar structure to particle base. In fact, I could probably actually make it... Yes, actually, I'm going to make it inherit everything from particle base. So it's going to be particle base. And then I'm going to overwrite the update here. So I'm going to void override update. Override void update. Okay. So I'm going to particle base. Make update be protected. I don't know. I'm just gonna keep attack base here, and I'm gonna keep it void at the moment. We're gonna see what happens. All right, cool. All right, so this update is going to have a different movement system to the particle base here. But this command here is going to have an order system that is going to be the attack base, which I'm going to apply to a game object here. So I'm going to create an empty, and I'm going to call this attack order, I guess. And this is going to have an attack base applied to it, and it's going to have a particle system attached to it. However, this renderer, yeah, no, I need to have the material selected. So this one's going to have the default particle, which is what everything has, right? Default. Okay, it's default particle system. This one, which is slightly more faded or more happy or something like that. I don't know. So this is the default particle. It's not going to have any emission, not going to have any shape, and it's also not going to have. Or well, all of these don't matter at the moment because these are just the start lifetime. And what I'm going to do is I'm actually going to make the particles that are applied to this using the command structure in the command here to have essentially unlimited lifespan because they're going to be dead soon anyway. So it's going to have. I'm actually going to here. I'm going to make it a p dot life p dot no. Yeah. No. LPJ. LPJ dot remaining oopsies. Remaining lifetime equal like 999. So I'm going to reset its lifetime. LPJ dot, what else should I make it? Yeah, it should be fine. Yeah, so I'm gonna make the lifetime equal 999, and that's gonna be fine. Okay. Fick. Okay, so the remaining lifetime is 999. It's gonna add that to the list. And then my order system dot ps dot set particles is going to be p dot to array. There it goes. So that list, I'm going to convert it into an array, and I'm going to set the particles of the order system to those particles that I've just done here that I've edited to have 999 life and things like that. Okay, so the other thing I need to do in particle base is have a variable which is its alignment. So 0 is neutral, 1 is player, 2 is enemy, 3 is different players and whatnot. But I'm just going to do player and enemy. I'm not going to have more than 2 players at the moment because it'd be really hard. It'd be hard. Anyway, so I'm going to have an alignment variable, so int alignment, alignment. Set that to 0. I'm going to make this public. Public int alignment equals 0. And this will determine the alignment of the base. Actually, I'm not going to do it here. I'm going to do it as an XML comment. All right. So this will determine the alignment of the base. 0 neutral. 0 equals neutral. 1 equals player. 2 equals enemy. 3 greater than 2 equals other enemies. Potentially other enemies, and it's going to be less than or equal to 0. No. Okay, so less than or equal to 0. Oh no, it's just that. Okay, fine, that's fine. I don't care. All right, 0 equals neutral, 1 equals player, 2 equals enemies, and greater than 2 is potentially other enemies. Okay, so that's that. Do that, and boom. Okay, cool. And then I'm going to have I like to call a library. I'm going to have a library of colors. So I'm going to have a library of colors, and that's going to determine what colors the particle systems are going to be. So I'm going to have inside another folder, I'm going to call this one, I guess, colors. I'm just going to call it colors, and I'm going to spell it with a U because I'm a filthy imperialist. All right. Sneezy. Yeah, no, yeah. All right, so I'm going to create. Can I create just a color? Just a color? Can I create a color? Can I have it as a thing? A color? I guess, is it a material? No, actually, I can't have actual colors. But what I will do is in scripts, I'm going to have another C# script called color library. Can I have a color library? Right. And inside this color library, it's not actually going to be an inheritance of mono behavior, so I'm not actually going to attach it to anything. This color library is actually going to be a public static class. Ooh, very, very fancy public static. Okay, it's going to be a static class, and I'm going to have public static. Can I have color representation of RGBA colors? And what does the particle systems use? However, if I go into attack base and then go ps dot live particles 0 dot color. There it is, right there. And it is, oh, it's deprecated. Okay. Start color is not what I want. I want the current color. Or does that actually determine what it is? The initial color of the current color of the particle is calculated procedurally based on this value and the active color modules. Okay, so I do actually need to define the start color. Okay. And it is a color 32. So that's what I need to set it as, a color 32. So I need to go into color library, public static color 32. And I'm going to call this one, oopsie daisies, player color. And I'm going to set it to new color 32 RGBA. So whatever this color is that I've set here. So this one, let's have a look. R is 0.41. I'm actually going to make that, I'm going to put it over here so I can, oh, it goes away. Bollocks. All right, so I'm going to make this 0.5 and 0.7. That's going to be my color. 0.5, 0.7, 1, 1. All right, and that's fine. 0.5, 0.7, 1, 1. So that's 0.5 F, 0.7 F, 1, 1. And these need bytes. What? How do I make a byte in Unity? Oh, good lord. How to make a byte in Unity. Actually, it's more like I need to do it in C#. And I'm pretty sure it's just, float to byte for color 32. Oh. Okay. So I need to multiply that by 255. Multiply each of these by 255 because that's the maximum value of a byte. And then I just need to byte like that. Just like that. Oops. Easy. And now this is, oopsies. This is the default setting for the player color. Cool. I'm actually going to have another one. I'm going to call it public static color 32. And I'm going to call this one neutral color. And I'm going to put U's in there. I'm not even sure if that's in the right place. Honestly, I've desensitized myself. Okay, it is in the right place. Okay. The second row has the U next to it, ladies and gentlemen. Neutral color, and of course I'm going to do the exact same thing, except this time all of the bytes are going to be... oh, okay, so you don't have spaces near that one. Oh, go ahead and run to the store. Get those things that you need. Yeah, I hope the Unity goes well too. I can only hope that instance. But thanks for coming around, Cadet. I always appreciate your company. And I always appreciate you being here. So go ahead, run to the store, and have fun for tonight. And hopefully you get there before the store closes. So that's gonna be good. Knock on wood. All right, cool. Is this even wood? I don't even know. I don't even know. Okay, so we've got a neutral color, we've got a player color, and then we're gonna do public static color 32. Bye. Enemy color. Cool. Color 32. Same thing again. Except I'm going to get the values for the enemy color. So here in base 1, we've got 0.5 and 0.5. There we go. Cool. 0.5, 0.5. Easy peasy. And that's going to be the enemy color. Cool. So 1, 0.5, 0.5, 1. So I'm going to go ahead and just copy this. So this one's going to be 1, 0.5, 0.5. And it can be a double if it wants to be, but I'm going to make it that one. Yep, 1, 0.5, 0.5, 1. And then I can do enemy 3 color, enemy 4 color, enemy 5 color, so on and so forth. And this is actually, like, if you want, it's actually potentially possible to make these values editable by the player. Since it's a static value, you can edit it anywhere and it will update based on the things that you want. But you need to make the interface to interact with that, and that's not going to be for a long time. But right now, these are the colors that are going to be. Okay, so what I am going to do is go to the bathroom. I could actually make these arrays, and I think I might actually make these arrays so that I can use the alignment int here. Where is it? Yeah, I can make the alignment int here actually be the index to the color. So if I make it into an array, I can actually just do the index thing, and it makes it a lot better. So I'm just gonna be right back. Yeah, no worries, no worries. I did a piece last time. Now I've got to do the other one. Shut up. I can get rid of that. And I'm going to get rid of that too. Cool. All right. So. Damn it. So. Neutral. One player, two enemy, two potentially other enemies. Okay. So this color library, I'm going to convert this into a public static color 32 array. I'm going to call this player colors equals new. Can't I just do this? No, this. Yes, I can. All right, cool. So this is going to be neutral. Boom. Dingus. All right, this is going to be player color. 1. This is going to be enemy color. 2. Okay, cool. And I'm not going to have it on the one line because I'm not crazy. So that's 1, 2, 3. And then that is gonna have that right there, and then that. Easy. Easy lemon. Cool. Right, get rid of that. That's fine. Okay, brilliant. So yeah, you can see that now the player colors here are going to be defined by these array of bytes, array of colors, that is, that I can then use the alignment to determine what color it is. And of course, again, I can I can make an interface to interact with this array to change the variables if I so choose. Now, since this is a static class, I can access it anywhere. I can access it anywhere using anything with any time. So here, what I'm going to do is panic. All right. Actually, what I'm going to do here is at start, I'm gonna make a function called recolor. So void recolor particles or color particles. Yeah, color particles. And it's just that. It's gonna be that. And what I'm going to do is I'm going to do particle system dot start color. No. Particle system dot main dot start color. So I'm pretty sure I've got PM. No, up here I should have particle system dot main as set to something. Yeah, I do. PSM. So PSM dot start color equals, ready, check this out, color library dot player colors, right, alignment. Player colors alignment. Feck. What? Who? Damn it. Hang on. No, I have to do it based off of all the particles. So recolor particles, and then it's got to go. Copy. I'm just gonna paste this. I'm gonna copy this, then paste this. Okay, and then I'm gonna do p dot p I. Okay, so I'm gonna p0 for now. Dot start color equals color library dot player colors alignment, because the start color is what, like as it says, it it progressively, iteratively, procedurally determines the color of the particle based off the start color and the lifetime color thingy. So that's good. So it's each individual particle that I need to do it. So for int I equals 0, I less than p dot length I plus plus. You'd think I'd have more fun with for loops, but I've made so many of them. So for I equals 0, I is less than the length of p, and I plus plus, we're going to change the start color to whatever alignment is, and it's going to, boom, do that. So here, what I could do is I can put in start because like I don't want to have too many grabbing all the particles, changing something, and then setting all the particles again during a frame, because that would slow down the process of it. So I only want to do it when I need to. So here at, I think I should do it in late start. Color particles. this. Huh? Wait, what? Wait, what? Oh, that gets okay. That gets rid of the bursts, right? I forgot. Oh, hang on. No, wait. So this in Awake, I can make psm.startColor equal the player alignment colors. No, I can't. Yeah, I should be able to actually. Color library. Start color. I ran into this problem before, didn't I? That annoys me. Why must you do this? Who are you to accuse me? Yeah, because what I want to do is be able to have, and this would make a brilliant menu screen as well. What I want to do is be able to have armies that are en route to each other when they arrive, like when they collide with each other, to attack each other just immediately. So one thing you can do is to halve the strength of the incoming army by sending out a squadron, and then wait for the respawn time to get up to you, and then yeah, so it'll attack. And the thing is that when a particle attacks, that particle will kill the enemy particle, but it'll also die. So in the end, it doesn't really matter who attacks first, because what I'm going to do is I'm going to do, like, when it's ready to attack, it's going to set a random variable between 0 and 5, and that's the amount of seconds later it's going to attack. Doesn't really matter who attacks first, because both of them are going to die anyway. So yeah, there's that. Sleepy boy. Very sleepy boy. So the particle's going to stop. It's going to wait for 1 to 5 seconds, and then it's going to attack a random particle inside the thing. It's a thing. But of course, if all the particles are dead, then it's going to continue on its original path. I'm a sleepy boy. So, right. Come on. Do I have to do... Oh, good lord. Particle system dot min max gradient mmg, right, equals start color. Good fucking lord. And then mmg dot color library, player colors, alignment, and then mmg, oh no, ps fucking psm dot start color equals mmg. Because particle systems are fucking terrible to work with. Why did I decide to do this? I'm a dingus. Okay, cool. I'm fine. I'm fine. I am fine. Right. Sweet. So, I haven't actually done anything yet, but this should work. Okay, so what I'm going to do is I'm going to set this one as 2 alignment, this one as 0, and this one as 1. So as we can see, the text isn't going to change. So that's going to be our, see, it's actually going to work. So the one on the left should be enemy. The one on the right should be, the one in the middle should be player, and the one on the right should be neutral when I press play. Let's have a look. Well, they are, but they're the wrong colors. Why is that the case? Interesting. Case of... Oh, okay, hang on. If I play it right now, boom, the one in the middle, let's have a look at its color. So here, this has it 001, and that's not what I want. What I actually wanted it to be was 0.5, 0.7, 1, 1. Oh, dingus. Absolute bloody dingus. I need to put this, because it's converting 1 into a byte, and then multiplying it by a certain number, which doesn't make sense using with byte mathematics because it's dumb. Okay, so that should be better. Let's try it again. I was right. Cool. So yeah, you can see that the colors have changed, and they look pretty good. And you can see that since this is the one in the center is the player aligned one, it's that blue color. And then, you know, the one on the right and the one on the left is the same, the right colors. Although it's roughly the color that I wanted it to be. Let's have a look. Yeah, no, it is. It is the colors that I wanted it to be. God damn. All right. The only thing, of course, is that the text is the wrong color, so I need to make sure the text is changed. And the way I'm going to do that is by in the particle base, in the recolor particles or the color particles things, I'm actually going to have the text, because the text is actually referenced in here in the update base text. So you see this tm.text equals ps particle count dot toString. I'm going to have a tm.text tm.text.color tm.text tm.color. It should, yeah, color equals color library. This is why it's so good to have libraries in your thing. Player colors alignment. And I need to make alignment have a lowercase a, because that's proper naming convention. Cool. Alignment, that. Cool. And I'm just going to go ahead and refactor that to make it be alignment. Cool. Apply. Nice. Very good. All right. So now the color of the text should change as well. What? I don't get it. Oh. Right, I changed the I'm a dingus. I changed the numbers here. So I'm gonna make this one 2, this one as 0, and this one as 1 again. Like I had said before. Okay, let's go. Boom. So yeah, so now we can see that, yeah, the colors, the text colors is right. It's exactly the same as the color of the things, which, you know, I kind of jive with, to be honest. If I'm being perfectly honest, I do kind of jive with the fact that the text is the same color as the particle system, but I might change that later on. It really it doesn't really matter all that much. I can also change the color of the text independently from the color of the players. That's one thing that I can do. So it's really just it's something that I'm going to make a decision later on. But right now it's pretty good. It's pretty good. And the best part is I can change it. I should be able to change it ad hoc. Well, I can't actually. I haven't actually set the things to be able to change ad hoc, but that particle system in the middle technically was aligned with neutral at that point in time. I need to find out a way to make it so that it... Actually, current alignment is going to be a private int that's going to equal alignment. Actually, no, it's just going to equal 0. Okay, cool. And then every update, it's going to check to see if current alignment does not equal alignment. If current alignment does not equal alignment. And that means I can get rid of this. Don't need to worry about it. If current alignment does not equal alignment, then we're going to make current alignment equal alignment, and we are going to color particles. Boom. So now, every time the current alignment changes, the particle colors are going to change. Right. This one started off with 0. I should actually start off the all of the text colors with 0. So I should actually start off the text colors, these texts here, with white. I should actually start that off with white. So they're all starting off as white. And then, boom, right, they're the right colors. And now what I can do is I can set this one to say 1, and then boom, suddenly it's a player color. But the initial color doesn't change. The start color here doesn't change. So in recolor particles, or in color particles, not only do I need to change the start color of each individual particles, but I also need to change the PSM dot start color to be the same thing. So player color, color library dot alignment, like that. So now all of the particles that get spawned later on are going to have the same color as the rest of the particles that are already there. Min-max. Okay. Okay. So what I'm going to do is I'm going to refactor. I'm going to refactor this out, and I'm going to put it down here. I'm going to say void change particle system main start color, and I'm going to do int. Oh no, I don't really need int alignment there. Right, cool. And I'm going to put this, and I'm going to put it just in here because so dumb. I can't just change the color. I have to put the min-max gradient into a list, and then I have to change the min-max gradient, and then set the thing that originally of the min-max gradient that I changed. It's so stupid. That's why you need to use pointers, people. Pointers, people. All right. It's fine. It's fine. It's fine. It's fine. It's fine. Okay, cool. Yeah, we don't need that line. That was originally setting the maximum particles to be the max particle set here, but I changed that by adding... Where is it? I fixed it. I essentially changed it by adding this here. Yeah. So if the particle count is over the max particle, we're going to calculate this overflow, which I'm actually going to reduce. And then this decay rate, which I'm also actually going to reduce by increasing... I'm actually going to reduce this by increasing this by ×2. Or something like that. So we're going to see what happens. Okay, so then when we start, doesn't exist, it's out of rounds, and it broke the thingy. But it's fine. Oh. It's okay, since it was a static variable that was out of bounds, it didn't do anything. Cool. Alright, so I'm just going to check real quick what I changed here. So it's going to come up, and then what I'm going to do is I'm going to, just like this. So you can see how it goes down quite a bit slower than I did before. I might actually keep this to be that. So it's going to do the exact same amount, but it's going to be half as fast. So it's going to slow down the reducing. Right, I need to at awake here. I need to no. What do I call it? This long fucking thing. Change particle system in max main start color. Fucking massive bloody ridiculous. All right. Okay, cool. And so now it's going to start exactly the way it's supposed to be. It's great. And it's great as well because I can change this here outside, and you can see how it's all black over here. Yeah, I can change it outside and then make there to be a lot of them. Whoopsie daisies. There to be a lot of them. You see, and that's all black. And then I can change all of the colors to be what they're supposed to be, which is kind of cool. And now, if you've put 1,000 onto the one that can only hold 100, that's still a bit too much. Still a bit too much. So I think what I'll do, because okay, so doing that reduced the amount by 10, so that actually reduced it by 20 times slower. So what I'll actually do is I'll make this, I think I might actually keep this one the same, but that is now the same as before because it's twice as slow. And I think I might actually make it 50 times because it's 2.5 times slower than previously. So it's now 5 times slower, 2.5 times slower than the previous test. So let's have a look. All right, so this one, I'm going to go ahead and set the thing to 100,000. Boy. Cool. Okay. And then I'm just going to... That's a lot better. That's a lot better. And you can see when it's 3 times over, you can see how it starts slowly reducing the numbers of the thing. And you can also see how... as it gets closer and closer to the actual maximum, it actually slows down the decay time. So I guess it actually slows down when it actually kills off some particles, which is desirable. The only thing about that now is that if I do this, you see how it took a little bit for it to speed up again? Not a problem. It's not a problem, honestly, because the time it takes for it to decay, like you're not gonna in actual play, you're not gonna reduce the amount of maximum particles you can have in a thing. So it's not a problem. So if I just go ahead and make this go back up, you can see it go all the way up 6, and then say that you put 1,000 particles, 1,000 army troops onto one area, you can, and then you can see that happening there. Very nice. Oh, whoops. It's going down. Going down to 0. You can see it going down to 0. So obviously, I wouldn't want to have the like the actual attacking be as slow as this. No, it's going to be, like I said, it's going to be anywhere between 0 and 5 seconds, 0 and 10 seconds, a variable that I can change. and that's how long it's going to take for a base to be overcome by enemies and whatnot. So when it gets to about 25 over, it slows down massively. You can see it's going very slowly now. Essentially every second, one gets destroyed. And it should get even slower than this. And you can see the individual particles blowing up as well. I always like that, it's fun. Yeah, so it's the minimum is 1 every second, and yeah, the maximum is unlimited technically. So I can set this to 10,000, and you'll see how fast the particles are able to destroy themselves. So we can see how much this actually grows up. I'm not sure if I'm going to want to have the 3D aspect of the fact that they're actually spheres and not circles in the game. I don't think I'd want to. But yeah, so this is just letting you know that that's how big it goes. And if we make this go down to 0, we're going to see a lot of lag. You can see how quickly it goes from 10,000 to 9,000 to 6,000 to 5,000 to 4,000, and then even further 1,000, and then 6, 5, 4, 3, 2, 1. See how much slower it is now. This is currently the amount over the maximum. 0, like 10, 90. 80. It's getting rid of 2 of every time. 2 every time. Minus 2, minus 2, minus 2, minus 2, minus 2, minus 2, minus 2. And now it's getting rid of 1 every time. And 1 every second. So yeah, that's what it's doing. And it's getting pretty good. Yep. And we can see the thing here. The time plus the decay rate divided by the overflow. So the overflow currently is 50, and so we're dividing the decay rate, which is 1, by 50. How does that work, actually? I can't remember how it works. I can't remember how it works. I know what the overflow is. It's the minimum amount minus what it currently is minus the maximum. So that's the amount that's over, and we're dividing it by 50, and we're getting to the seal. So at 50, oh right, yeah, of course, right, yeah. So this is currently at 1. The overflow is at 1 because it's less than 50. So it's at 1. So our seconds is the decay rate divided by 1, which is just 1. So as soon as it goes below 50, so as soon as it's like any multiples of 50 slows it down. So it's at 4 times speed at 400 at 200, and then 3 times speed at 150, and then yeah, 2 times speed at 100 and below, and then 1 times speed at 50, and then it's gone back to 0, which is cool. We can see that again if I just go up to 100 and get rid of it. You can see it's getting rid of 2. Actually, if I bring it up to 500, this one should reduce it by 10 every time. So if we then get rid of it, yep, 10, and then 9, 8, 7, 6, 5, and then 4, and then 3. See, it's reducing by 3 every time now, and then 2. So it's reducing by 2 now. So yeah, it's pretty cool. It's pretty cool. Yeah, it's pretty cool. Yeah, it's pretty cool. Yeah. And now it's reducing by 1. So that's cool. Yeah, I'm fine with that. Very cool. And the other thing you can see here is that the death particles are spawning actually above the where it is, and it's actually going slightly crooked, so it's actually going 60 degrees off center, so it's always going to appear as if it's going upwards slightly. But the reason why this is important is that I have to make sure that new death particles don't appear above old death particles, and I have to make sure that none of the active sprites appear above the death particles. So yeah, it's just interesting. Okay. And then of course when it reaches 0, we can align it to player, and then they can get up to 100 and whatnot. So yeah. So that's that. Cool. Cool. This is coming along quite nicely. I am very tired. But the good part is that I now have all the default values for a base. And what I can actually do is I can make this base here. Let me just make this to 0, 0, 0. I can make this base here be a prefab. So I can go assets, create folder, and I'm going to name this prefabs. So these prefabs, boom. Particle base here. I'm going to name this particle base. So this is now going to be a prefab with all default variables set, and it's important. That's good. Yeah. So now what I could do is actually my attack order can spawn in a particle base with 0 emission, maximum setting of unlimited, essentially, and the alignment of the player's alignment. And when and then I'll do something with that. But I need to take a break. I need to take a break because I'm a sleepy boy. I've been a sleepy boy this entire time, but I've managed to hold it off. But now I just can't. I'm so sorry. So yeah, this is what it is right now. Hi, how's it going? But yeah, so that is all at the moment. So thank you so much for joining me on this live stream. Very random live stream, very random time, but it's what it is at the moment. So there you go. Yeah, so thank you so much for joining me. I will see you next time. I don't know when the next coding stream is going to be, but I hope to be able to do another... it was Tuesday today, wasn't it? Oh, rip. Today should have been Tutorial Tuesday, but that's fine. We can see about doing another stream either tomorrow or the day after or something. I do also want to get into Twitch streaming. So I think I plan on doing some Beat Saber later today. Maybe not, because I'm very tired, and Beat Saber was the reason why I'm tired, because I did Beat Saber yesterday. And I also kind of want to get into like Call of Duty or Titanfall or something like that. But it's really just, man, it's just what it is, man. It's just, it's just what it is, man. It's just, yeah. That's all good. Alright, anyway, thank you for joining me. I will see you in the next video. Bye-bye. Goodbye and good luck. Alright, that's what I meant to say. Alright. And